Multiplying polynomials. To multiply polynomials, this is what it looks like. We're going to distribute each term from one polynomial to each term in the other polynomial. Then we combine like terms, and we'll write from the highest degree to the lowest degree. So this is based off of the distributive property. Visually, the distributive property says a times b and a times c is the same thing as a times b plus c. So here's a, here's b, here's c. So this is 3 times 2 is 6. 3 times 5 is 15. And that's the same thing as 3 times 7, which would give us a total of 21. So when we do that algebraically, what you see is this. This is multiplication. 6x times 2x is 12x squared. Remember, x times x is x squared. 6 times 11 is 66. We keep the negative and x. So what we're going to do now is we're going to do this with two binomials. So what we have is x plus 3 times 2x plus 5. What we're going to do is we're going to distribute x to both of these, as well as distribute 3 to both of these. So when we do x times 2x, that gives us 2x squared. Then we're doing x times 5, which gives us 5x. Next, we're doing 3 times 2x, giving 6x. And lastly, 3 times 5, giving 15. The like terms are 5x and 6x, so that gives us 2x squared plus 11x plus 15. A more intuitive way of looking at it, not faster, actually a little slower, but makes more sense to some students, is to draw it out in this table. And now we're doing x times 2x to get 2x squared, 3 times 2x to get 6x, 5 times x to get 5x, and 5 times 3 to get 15. All of these were positive, so then we'll go from this table, and then you see the exact same things written there. So I'm not going to do it with the table, but you're certainly welcome to. We're doing x times x is x squared. X times negative 7 is negative 7x. 1 times x is positive 1x. And 1 times negative 7 is negative 7. These are like terms, giving us x squared minus 6x minus 7. Watch your signs. Realize that the negative 7, that negative is attached to the 7, so that's why this was negative and that was negative. In this one, there aren't any negatives to worry about. So x times x is x squared. X times 2 is 2x. 9 times x is 9x. And 9 times 2 is 18. For this one, I'm going to draw the arrows as I use them. So x times x is x squared. X times negative 3, be careful with the negative, negative 3x. Negative 5 times x, again, be careful with the negative, negative 5x. Negative 5 times negative 3, 15. These are our like terms, so we get x squared minus 8x plus 15. Same process here. So x squared minus x. When we do the second set from the 15 halves, we get plus 15 halves x minus 15 halves. Again, the middle terms are usually going to be like terms, not always. We'll get to those soon. Plus 13 halves x minus 15 halves. So here, this is an example where they're not going to be like terms. So 2z times 3z squared is 6z cubed. 2z times 1 is positive 2z. Negative 1 times 3z squared is negative 3z squared. And negative 1 times positive 1 is negative 1. Now, typically, we'll write these in the highest exponent to the lowest, but there aren't any like terms, so we'll just leave it as is. So you see all of the numbers stay the same. I just switched the order of these so that the higher exponent, the squared, came before the linear term. Here, what we're doing is we're going to distribute each piece. So x squared times 11x will give us 11x cubed. X squared times 10 will give us 10x squared. Now we're going to do 2x times each of these, so 22x squared plus 20. Last is 3 times each of these is 33x plus 30. Now there's multiple sets of like terms. There's one set of like terms there, and another set of like terms here. So we still have the 11x cubed, we still have the positive 30, and now we need to combine the like terms. The x squared term is 10 plus 22 is 32. The x squared stays the same. I just realized I made a mistake. When I did 2x times 10, that should be 20x. I already knew that, so I drew this as like terms, but just be careful about that. And then 20x plus 33x is 53x. All right. So more like that. Here we have 3 sets of parentheses, so I'm going to do 2 of them first, and then do the second one later. So x squared plus 4x plus 3x plus 12, and that's going to be multiplied by x plus 5. Still simplifying the left part of this expression. I'm combining like terms to get 7x. Now we distribute the x squared, just the same as we did in the previous problem, so we get x cubed plus 5x squared. Distributing the 7x gives us 7x squared plus 35x. This is where I lost that variable there. And now 12 times x and 12 times 5, 12x plus 60. So the like terms, there is our 2 sets of like terms. X cubed plus 12x squared plus 47x plus 60. It still works if we have variables. So x times y is xy, x times z is xz, y times y is y squared, and y times z is yz. So that's going to now be multiplied into the z plus x that we haven't used yet. So each of these gets multiplied in to the second set. So xy times z is xyz. Then xy times x is x squared y. Now we have xz times z is xz squared. Xz times x is x squared z. Gonna have to use all my colors here. Y squared times z and y squared times x will be y squared z and x y squared. And the last one, yz times z and yz times x. So yz times z is yz squared. Yz times x is xyz. All right, so I think we've done all of them, and now there's only one set of like terms. The xyz and xyz are the only like terms here. So now we have to write them. X squared y plus xy squared. So let me cross them out as I use them. Plus there's 2 xyz's. And now I've used I haven't used the x squared z yet. It really doesn't matter that much. It's standard to go in alphabetical order. So let me do this from the beginning correctly. X squared y, x squared z. So now that's taken care of. Now xy squared 2xyz. So now we're up to date. There's one more term with x's, xz squared, and now y squared z before yz squared. You're not going to see many of these, but it still works no matter how complicated the numbers or variables are. The commutative property still works, so you can still do these two multiplied together first. So if we did s times s, s times negative 1, 1 times s, 1 times negative 1, we get s squared minus s plus s minus 1, and then we still have the s squared minus 4. Now be careful, as you do this, it's still the quantity multiplied together. So this is s squared minus 1, these added to 0. And then we have s squared minus 4. So if we multiply these, let me close those parentheses. S squared times s squared is s to the 4th. S squared times negative 4 is negative 4s squared. Now we have negative 1 times s squared, and negative 1 times 4 is positive 4. So s to the 4th minus 5s squared plus 4. Lastly, this one's kind of fun the way that it works out. If we do u to each of these, it will increase the exponent on each of them. So we end up getting u to the 6th, u to the 5th, u to the 4th, u to the 3rd, u to the 2nd, and u. So that's from multiplying out the u. From multiplying the -1, we get the opposite of each of those. So negative u to the 5th, negative u to the 4th, negative u to the 3rd, negative u squared, negative u, -1. So there's a bunch of like terms, and in each of those like terms, it's a positive and a negative, so they add to 0. We're left with u squared minus, or u to the 6th minus 1. And that is how we multiply polynomials. So what we did was we distributed each term from one polynomial to each term from the other, combined like terms, and wrote from the highest degree to the lowest. Thank you.